Okay, so now we're going to talk about the quadratic formula and its discriminant. So the quadratic formula is actually this, all right? So just to make sure we understand what it's for, so instead of factoring something like this, for example, if you don't want to factor this, then your other option is the quadratic formula, all right? Where in this case, for example, a is always the number that's in front of the x squared. In this case, since there is no number, a is 1. B is -5, and in this case C is -14. And if you plug that in right into this formula, then you should be able to get the roots of the quadratic function or the solutions. Okay, so now we're going to go ahead and talk about a few of these. All right, so we're going to do some of this. So on number 1, if you look at it, right, you have x squared minus 11x plus 24. Now they're asking us to use the quadratic formula to solve this. So in this case, a is 1, b is -11, and c is positive 24. All right, so again, if you look at this formula, and I'm going to rewrite the formula here so hopefully you can tell what I'm doing. So you have negative b plus or minus b squared minus 4ac all over 2a. Okay, so again, negative b plus or minus the square root of b squared minus 4ac all over 2a. So now b in this case is going to be -11, so x is equal to negative of a -11 plus or minus, and then you write all this stuff here, -11 squared minus 4 times 1 times 24 all over 2 times 1. Okay. Now if you kind of multiply that and simplify, you can always do it like this. This is 11 plus or minus, this is going to be 121 minus 96 all over 2, which will give you 11 plus or minus square root of 25 all over 2. And then now I know what the square root of 25 is. It's 5, so I have 11 plus or minus 5 all over 2. Okay, so then at that point, a lot of kids that normally use all of this correctly, but they kind of mess it up here at the end. Remember, the 11 plus or minus 5, that's actually 2 solutions. So what you can write, one solution is going to be x is equal to 11 plus 5 over 2, which in this case that's 16 over 2, which is 8. So that's one answer. And the other answer is x is going to be equal to 11 minus 5. That's what the plus or minus really means, right? You have two different numbers over 2. So 11 minus 5 is 6, and 6 divided by 2 is 3. Excuse me. So on this one, I have two roots, two rational roots, and x is equal to 8 and x is equal to 3. Okay. So I'm going to go through number 2 also. Well, actually, you know what? On number 2, I'm going to let you do it yourself. Try this. If you do it correctly, you should get x is equal to 3 and x is equal to -5 over 2. So that should be the answer for number 2. Try that out. Pause this. Do it. Okay, so instead I'm going to go over, let's see, let me go over number 4, right? So number 2 and 3 are basically the same. Remember, you have two solutions. Okay, so I'm going to say that x is 4 and 4/3, so try that out. All right, on number 4, we're going to go ahead and do number 4. In this case, a is 1. B is -10, and C is -50. Alright, so we're going to go ahead and use the quadratic formula, which again is right here. So we have x is equal to -b, so this is negative of a -10, plus or minus b squared minus 4ac all over 2 times 1. Alright, so let's be real careful. Don't get in a hurry. Let's do this right the first time. So we have 10 plus or minus Now, if you want to use the calculator in this, I mean, you're more than welcome. If I do all of this, for example, just be real careful if you're going to use the calculator. That should be, I mean, I know this is 100. So we have that minus 4 times, oops, excuse me. Let's see, minus 4 times A1, so negative 50. I think that's going to be 300, but okay. So it is going to be 300 all over 2. Alright, so now to go on, notice that 300 is not a perfect square, so you're going to have to simplify that radical by looking for factors of 300, basically doing a factoring tree. Now, on 300, alright, now that you guys are maybe a little bit older, what I like to do on these, I like to look for perfect squares within this. Now, I know that this is 100 times 3. Alright, and I know that 100 is 10 and 10. And as soon as I see a pair, I stop. Alright, because 10 and 10, that's it. Alright, I have a pair and I have a 3 left over. So this is going to be 10 plus or minus 10, remember that 10 came from this, square root of 3 over 2. Now the next step is critical. You don't want to go that far and get it wrong. Remember that this is essentially 2 answers, okay? So this 2, you can only reduce this only if this number and this number and this number, all 3 of those, not the square root, don't touch whatever's inside the square root. Right, reduce those 3, or divide in this case, so that's going to give me 5 plus or minus the square root of 3, excuse me, plus or minus 5 square roots of 3. Okay, so again, make sure you can reduce all of this and never touch whatever's inside the square root. Whatever's inside the square root needs to be left the same. Alright, let's go over something like number 5, right? So I'm going to go through this one pretty quickly. So we have A is equal to 4, B is negative 12, C is negative 63. So this is going to be, looks like it's going to be pretty big. So X is equal to negative of a negative 12 plus or minus the square root of negative 12 squared minus 4A. No, in this case, A is 4. This is 4. C is 63. All over 2 times 4. Okay. So this is X is equal to positive 12 plus or minus some number. All over 8. Let's see what the square root of this is. Please be careful, this is a negative 63, right? So I almost messed that up. Okay. So I'm going to rewrite this. I have negative 12 squared minus 4 times 4 times a negative 63. Okay. Oh my. 1152. Okay. So let's look. I want to use the calculator to sort of reduce this to its maximum point. Okay. So on this one right here, so I'm going to write the factoring tree for this one. So I have 1152. Remember what I'm doing is I'm basically trying to find the biggest square factor. So in case you're wondering, to do this maybe faster, I always divide this by 4. And if I get that, then I go back and do it by the next square number. And I'm going to choose the next, like for example, if I divide this by 9, okay, even better. If I divide this by 16, even better. Does that make sense? So that's how I'm doing it. So on this one, I'm even going to go ahead and use this. So 16 times 72. So 16 times 72. Okay, now 16 is good because I have 4 and 4. So that's that for that one. Now 72, luckily for me, that's 2 and 36. And 36 is 6 and 6. Alright, so I'm always looking for the square numbers. Right? You don't have to do it like this, but that's how I'm going to do it. So now this one I'm left over is a 2. So I have x is equal to 12 plus or minus, let's see, that would be 24. So I have a 4 here and I have a 6. So technically that would be a 4 times 6. And I'm left over with a 2. So let's see here. Okay. So I'm going to stick with that here, and I have divide this by 8. And this is going to be 12 plus or minus 24 square root of 2 over 8. Okay. So now my next step is to try to find a number that divides all of these 3 right here. Alright? I can't just reduce those 2 or those 2. All of these 3 have to be reduced, and whatever's inside the square root needs to be left alone. So find the biggest number that could divide all these 3. And I can't think of anything bigger than 4, so I'm going to divide all of these by 4. So this would be 3 plus or minus 6 square root of 2 all over 2. So again, I divided this by 4, that by 4, and that by 4. Alright, so this is your answer. Okay. Alright, last but not least, I'm going to do number 6. Alright, so number 6, I'm going to try to go through it relatively quickly. Actually, I'm going to go ahead and give you the answer because I'm going to run out of time here. X is equal to 3 plus or minus 2i square root of 3. Alright, so again, notice that on this, on number 6, you're actually going to get a negative. The reason I have an I out here is because I have a negative square root, which gave me an imaginary answer. Right? So again, be careful with that. One more thing I must point out, if you're graphing this and you were looking for the roots, the fact that you have an imaginary answer means that it does not cross the x-axis. Alright, so this, since it's positive, alright, so it's a parabola pointing up like this, it's going to be above the x-axis, so it's never going to cross through it or touch the x-axis. Alright, so let's go to the back, or in your case, let's go to the second page. And now we're going to talk about the discriminant. Alright, so the discriminant, if you look at it, I'm going to write the quadratic formula up here again so you can see it. Negative b plus or minus b squared minus 4ac all over 2a. Right, if you look inside the square root, that b squared minus 4ac, that's called a discriminant. Okay? Now, the only thing that the discriminant is for, if you write it ahead of time, is going to tell you what type of solutions you're going to get. Now, if b squared minus 4ac is positive, meaning you have a positive number and a perfect square. So, for example, if you would get the square root of 64, right? The discriminant is 64, which means you're going to get 2 rational roots. Rational just means any number that you can set up as a ratio, okay? Or in your case, it's just if it's a perfect square, you're going to have 2 rational roots, okay? Now, let's say that the discriminant, which is inside the square root, is positive, but it's not a perfect square. Like, I don't know, if you get the square root of 3, meaning the discriminant is 3, you're going to have 2 irrational roots. So an example of irrational roots would be basically what I got here. All right, on this problem even. Notice that the discriminant, whatever's inside of that, was 300, and there is 300 is not a perfect square, meaning you cannot take the square root and get a whole number back, or an even number, if you will, or just a whole number. And then if that's not the case, then you're going to have this is called an irrational solution. And you can tell them apart pretty easily because you basically end up with a square root anyway. So this is an irrational, that's an irrational, this is rational, okay, and those 2 answers, both of them would be rational. So, anywho, now finally, if this is exactly equal to 0, then you're going to have 1 root. So there's not much to say other than if you get this. See, the plus or minus 0 doesn't really matter. So, and then finally, if you get a negative, you're going to have 2 complex roots. So complex roots is basically what you're going to end up here. If this is less than 0, which means it's negative, okay, so that would be negative, then you're going to have a complex root. Okay, which means you have imaginary solutions. So let's go ahead and take a look. I'm just going to do a couple here. Okay, so the first thing they're asking you to do is complete parts A through C. So A, first of all, you have to set this equal to 0. So subtract, or in this case, add the 4 to the left side and set that equal to 0. So before you do any of this formulas, you have to do that. So now, I'm going to, on part A, I'm going to use the discriminant, which was b squared minus 4ac And I'm just going to plug all those numbers. Remember, A is 1, B is 12, C is 4. Alright, so this would be 12 squared minus 4AC. Because this is 128. Now, 128 does not have a square root. It's not a perfect square root. All right. So, for example, if I were to put 128, I'm going to get some kind of decimal. All right. Now, because of that, because this is not a perfect square, this means that part B, when it's asking what type of solutions, this is actually going to be 2 irrational solutions. All right. Then finally, C, they're just asking you to do whatever you did on the front page, which was use the quadratic formula. So in this case, I have P is equal to negative 12 plus or minus the square root of 128. Remember that 128 was the discriminant, or is the discriminant. So this is negative 12. Now 128, all right, I'm not going to do this forever, but I'm doing it one more time. I know that 128 is 64 and 2, and 64 is 8 and 8. You can keep breaking this down if you want to, but if I have a pair, I'm going to stop right there. All right, so I'm going to put that 8 out and then write this 2 on the inside. And remember what I said on the front page. What I said on the front page was that if 12, 8, and 2, those 3 numbers are divisible by some other number, all 3, then you need to reduce all these 3, right? Do not touch what's inside the square root. Now all of these are divisible by 2. So I'm going to write it as this. All right. So again, notice that my irrational solutions ended up with a square root like this. All right. So I know I'm doing this right now. On let's see. Hold on just a second here. Switching pages on my notes. Okay. So on this one right here, let's look at the discriminant. Okay. This is already equal to 0. So let's see. A is b squared minus 4ac. It may help you to write this formula over and over until you kind of memorize it. So we have a negative 6 squared minus 4ac. Now if you do the math on this, you're going to get 0. Alright, and if you get a 0, what that means is that you have one solution. One rational solution. And you're going to see why here in just a second. Alright, so on C, I'm going to go ahead and do the quadratic formula. So I have x is equal to negative b, which is going to be negative of a negative 6, plus or minus the square root of 0 over 2a. 2a is 9 here. So what is the square root of 0? It's just 0. So that really doesn't matter anymore. So all I have is 6 over 18, which is 1/3. So this is it. Alright, so this is, for you, if you remember that, this would be your double root. You don't have to know that necessarily, but it's nice, hopefully, to connect those to the graph. Alright, let's go over number, let's see. I'm not going to do number 3. If you do it, see if you can give me the, see if you can give me the discriminant. I want to give you the discriminant at least, I guess. 32. Alright, B, the B part, which is what type of roots. Remember, if you cannot take the square root of this is not a perfect square, so therefore B is going to be too irrational. I'll let you write that. But then C, if you do the quadratic formula, you should get, oh shoot, I think I did the wrong one in this one. This is actually 81. Alright, is this a perfect square? It is. Alright, so that means you're going to have 2 rationals. And your 2 answers should be a negative 1/2 and a 4. Alright, so you have 2 answers, and there they are. Alright, so try that out, see if you can get that. Alright. Finally, at number 4, I will like to do one of these. Let's see. Okay, so let's go ahead and do this one. So this is already equal to 0. A, I have to do the discriminant. So it's going to be a negative 4 squared minus 4a. Oh, a is 4. C. Okay. Let's see what that is. Alright, so that's a negative 160. And the reason I wanted to do this one is because, notice that because I have a negative number, then the square of a negative is going to give me imaginary. And if I have an imaginary, that means that I have two irrational solutions. Excuse me, two complex solutions. Okay, or roots. Now, to the quadratic formula. Okay, so to the quadratic formula, I have x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, which in your case that would be positive 4 plus or minus this number, negative 160, all over 2 times 4, which is 8. Alright, so I have 4 plus or minus negative 160 over 8. Okay, so negative 160. Okay, I need to break that down. So when I break it down over here, now I mean, remember, you can do 2 times 80, and then 80 is 2 times 40, but I know that this is 16 times 10, and 16 is 4 and 4. Okay, now this 10 is 2 and 5, so you can write it as 2 and 5, but it's not going to matter. So, to simplify this, I have x is equal to 4 plus or minus, the 4 comes out, the 10 stays in, all over 8. Okay? Now you need to find a number that reduces all of this. Now 2 can actually reduce all of these 3. Remember, do not touch what's inside the square root. So I have 2 plus or minus 2. Excuse me, I have 4 can divide all of these evenly, even better. Okay, so if I reduce this, that will give me a 1. And one thing I forgot here, because that's the square root of 160, negative 160, I'm going to have a 4i. So I have this all over 8. Okay, so again, one more time, the negative 160 inside the square root is going to give me an imaginary solution once you simplify that, once you break it down.